We're going to take a look at solving systems of linear equations that have three variables. It is absolutely critical that you keep your work very organized as you go through this process, because this is kind of a big process, and if you screw something up in the beginning because your work isn't organized, you're not going to know until the very end, and then you're going to have to start over. Same thing with negatives. You have got to pay close attention to negative signs. Don't just lose them in the mess of your work. In order to solve a system in three variables, we're going to end up using the combination method 3 different times for one problem. We're just going to start in with an example. So now, in order to solve a system that has 3 variables, I have to have 3 different equations. If I were to have 4 variables, I'd have to have 4 different equations. And just for easy reference, I've named each equation just A, B, and C. That way I can talk about them easier. Well, what we need to do is we need to set up 2 little mini systems of 2 equations. So I'm just going to take A and B and I'm going to put them together in their own little mini system here, and then I'm going to end up using the combination method to get rid of a variable, to eliminate one of the variables. Now at the same time, I'm going to set up a second mini system on the other side of my line here, and it cannot be A and B because I've already used A and B together. You can pick A and C, or you can pick B and C. I'm going to pick B and C. It doesn't actually matter which ones you pick. So set up your second mini equation on the other side of this line here. And this is just to help us keep our stuff organized. Now that I have my 2 mini systems set up, I'm going to pick the variable that I want to eliminate, and I'm going to go with the y. Now the reason I'm picking the y is because to me a 2, a 1, and a 3 are all pretty compatible. More compatible than a 5, a 2, and a 3, or a 4, 3, and a 5. You can pick any variable you want and it will all work out just fine, but I'm going to pick to eliminate the y's. Now if I eliminate the y on my left mini system here, I have to eliminate the y's on the right mini system here. So I have to just work on the left side now. I have to ask myself, what do I need to do in order to get the same coefficient but opposite signs? Well, to do that, I need to multiply the bottom equation by 2, distribute that 2 out, so I'm going to end up with that 4x minus 2y plus 6z is equal to 8. Now I can go ahead and add my 2 equations together, and I would end up with 7x. Now the 2y minus 2y goes down to a 0y, and then the 4z plus 6z gives me plus a 10z, and then equals 8 plus 11 is 19. Now I have an equation left that only has 2 variables. We temporarily stop on this side. Then we come over here to the other side and we have to do the same thing. I need to eliminate the y. So I have to ask myself, what do I need to do to my equation so I get the same coefficient but opposite signs? Well, I'm going to multiply the top equation by a -3. Now the reason I'm doing -3 is because right now the signs are the same, so I need one of them to be a plus sign. Well, if I multiply by -3, it's going to turn that into a plus sign. I'm going to rewrite this equation underneath my C equation. So when I distribute that -3, I would have -6x plus 3y minus 9z equals -12. So I've rewritten that equation there. Now I'm going to go ahead and I'm going to add these 2 equations, and I'm going to end up with -x. Then my minus 3y plus 3y will eliminate down to a 0, and then my plus 5z minus 9z will give me a minus 4z, and then -1 and -12 is -13. Again, I have an equation now that is down to 2 variables. We are going to take these 2 equations and now we're going to bring them together to make a new system. So what I've done is I've taken my 2 equations and I've rewritten them now to form my third little system here. So now I'm going to do the combination method a 3rd time. And I have to decide now which variable do I want to get rid of. Well, I'm going to get rid of my x's because I can change 1 into 7 a lot easier than getting 4 and 10 to match. So in order to do that, I need to have the same coefficient but opposite sign here, so I need to multiply my bottom equation by a 7. When I distribute that 7 out there, I'm going to get negative 7x minus 28z is equal to negative 91. Now I can go ahead and I can add my equations together. The 7x plus negative 7x goes down to a 0. And then 10z minus 28z is going to be negative 18z. And then my 19 plus my negative 91 gives me a negative 72. Now I'm down to a single variable, so I can go ahead and divide both sides by that negative 18, and I'm going to get z equal to 4. I have just found the first part of my ordered triple. Now what I'm going to do is I'm going to start working backwards. So since I have one variable found already, I'm going to take that variable back up to the system I just got done with, and I'm going to plug it in there to find my second variable. So if I plug it back into this top equation here, I have 7x plus 10 times z, well my z is a 4, and that has to be equal to 19. Solve that out and you get 7x plus 40 equals 19. Subtract 40 off and you get 7x is equal to negative 21. Divide by 7 and you get x is equal to negative 3. Now at this point, it's a good idea to check. And the way you can check this is by plugging it x and z into your other equation here. So I'm going to check, is 7 times negative 3 minus 28 times 4, is that equal to negative 91? So I've taken my x and my z and I'm plugging them into this bottom equation to see if it's going to work or not. Well, when I take my 7 times 3, or my negative 7 times negative 3, I end up with a positive 21. Take that 28 times 4 and I get 112, so I have minus 112. And if I take 21 minus 112, I get negative 91, which is what I want. So there's a good chance that I am on the right track because this x and z worked in these two equations. Now I need to go back and I need to find out my y value. Well, in order to do that, I have to go back to one of my original equations and plug in my values. Now that I know that x is negative 3 and z is 4, I'm going to go back and plug both of those into one of these three equations to figure out my y. I'm going to pick this middle equation here because it has the simplest version of y. So I'm going to go ahead and plug in my values. So I would have 2 times negative 3 minus y plus 3 times 4 is equal to 4. So I'm just going to substitute my x and my z value in so I can solve it for y now. So I have negative 6 minus y plus 12 is equal to 4. Well, combine my like terms, so negative 6 plus 12 is 6. So I have 6 minus y is equal to 4. Subtract 6 over to the other side, so I have negative y is equal to negative 2. Divide by negative 1, and I get y is equal to 2. Now, I have found all three of my variables, but I have to check them in order to make sure that I didn't make a mistake somewhere. In order to check them, all three of these equations have to be true when I plug in my x, y, and my z. So I'm going to go ahead and do that and see if it turns out right. I'm going to do my top equation first. When I take 3 times negative 3, I get negative 9. 2 times 2 is 4, and then 4 times 4 is 16. So if I do negative 9 plus 4 plus 16, I'm going to get 11. And negative 9 plus 4 is negative 5. Negative 5 plus 16 is indeed 11, so I get 11 equals 11. So it works in the top equation. Then I come down here and I plug it into the second equation. So I would have 2 times negative 3 is negative 6, minus 2, and then plus 3 times 4, so plus 12. That should give me a 4. Well, negative 6 plus negative 2 is negative 8. Negative 8 plus 12 is indeed 4, so I get 4 is equal to 4. So it works in my second equation. Then the last one, I need to plug it in here. So 5 times negative 3 is negative 15, minus 3 times 2 is 6, and then plus 5 times our 4, which is a 20. That should all be negative 1. Well, negative 15 plus negative 6 is negative 21, plus a positive 20 is indeed negative 1, so I get negative 1 equals negative 1. Since these three numbers worked in all three equations, I have found my solution. The last thing I need to do is write them as an ordered triple. So I'm going to write it as negative 3, because that's my x, then I do my y, which is 2, and then I do my z, which is 4. So there's my x, y, z pair, my solution to that system. So now remember, we started with two mini systems and eliminated the same variable. You have to eliminate the same variable. Then we brought those two new equations together and created our third system here, and that allowed us to solve for one variable. Then we went backwards. We plugged our variable into our most recent equation, found our second variable all over here, and then took both of those back to our original. Okay, so here's a practice problem. Go ahead and see if you can get this set up the way you want it to be. I'll tell you that when I do my two mini systems, I'm going to end up getting rid of the variable x. So if you want your work to look like mine, you'll want to get rid of the variable x. Alright, I started off by combining my a and my b equations, and then I did my b and my c equation. So I set up my two mini systems first. Then I went back to my first one and I multiplied a by negative 3 because I'm getting rid of the x variable, and I needed to have the same number but the opposite sign. So when I multiplied that out, I got this equation here, negative 3x minus 3y minus 3z equals negative 6. Now when I added those two equations, a unique thing happened here. My x's were eliminated, my y's were also eliminated, and my z's were eliminated. So I ended up with 0 equals 8. This is an expression that has no variable in it, so this is one of our special situations. And what you have to realize is that 0 equals 8 is false. So since this is false, we end up with no solution. I don't even have to go on and solve this one out for anything, because I already know right here that there's no solution. So there's no sense in me going on with the rest of the problem. What's going to happen here is these two planes end up being parallel to each other. So those two are never going to intersect. Well, I want to go back up here and I'm going to change the problem a little bit. I'm going to go ahead and, instead of equation A just being x plus y plus z, let's make equation A be 2x plus y plus z equals 2. So go ahead and solve this new system here and see what you come up with for your xyz pair. Okay, so for this last one, now that I've changed equation A, I set up my two mini systems with a and b, and then I had to multiply my top equation by negative 3 and my bottom equation by 2 in order to get rid of my x variable. Went through that work and I came up with 3y plus 3z equals 22. So that was my stopping point there. Then I came over to my second mini equation I had set up, which was b and c, multiplied my bottom equation by negative 3 so I could get rid of my x variables. And when that happened, I also ended up eliminating my z variables, which is really, really good because that's going to save me some time. Because I end up getting 9y is equal to 2. Divide by the 9 and I get y is equal to 2/9. So I have already found one of my solutions. Then I took that and I combined it with this equation right here. Now I could have gone back and I could have plugged it back into one of these equations up here and then set up a third system, but it is much, much easier to just take this y equals 2/9, bring it over and plug it in for my y value here, because that's going to allow me to solve it for z. So I plugged in my 2/9, ended up going through all the algebra here and got z equal to 7 1/9. Now I have two of my variables found, so I took both of them back up here to the original and I plugged them into the top equation. Went through that process to solve it for x, and I got x to be negative 2 2/3. So this one was a little bit shorter because I found one of my variables early, but you still need to check them all. So I plugged them into all three of these equations and they worked in all three of them. So I know my solution, my ordered triple, is -2 2/3, 2/9, and then 7 1/9.